Thank you so much for the introduction. Hi, everyone. I'm Joseph Poon. 大家好，我的名字是潘志豪. So today I'm going to be talking about sort of a high-level overview of scalability, and more scaling blockchains and sort of what we're dealing with in terms of the narrative of this space and where we're headed within the ecosystem. I think a lot of us are, perhaps sometimes a little bit overly focused when it comes to building narratives, when it comes to, the token ecosystem, et cetera, et cetera. But, as CryptoKitties has showed us, and the Bitcoin blockchain transaction fee value costs, like scalability is basically a blocker in this space. And scalability is something that is relevant to everybody, even the non-technical people, because it has impact of where we're headed as sort of what projects are viable within this space. So, for example, if we have the certain scalability abilities that we have today, obviously we can do certain types of high-value payments, certain types of transactions, certain types of high-value contracts. But can we sort of push the envelope? And the further we push the envelope, the more that blockchain can sort of like encompass global trade volume, and not just trade, but also computational volume, right? So there's a possibility that we can be looking at, putting entire things like Facebook on the blockchain and things like that. The primary impediment is not inherent technological constraints, but is around inherent technological constraints of the individual application, but is around technical constraints around scalability. So that means that if we can push a great deal of data on there with very, very low fees, then things like Facebook on the blockchain, WeChat on the blockchain, stuff like that starts to become viable, because right now it's not due to certain constraints. So if you're talking about understanding sort of what applications we can build on blockchain, fundamentally scalability is a core part of this solution, and that's sort of why I'm talking about it today, and why I'm one of the researchers on scalability. So how to approach this problem, right? Blockchains fundamentally deal with the nature of global consensus when we deal with the root source of truth, right? The blockchain fundamentally is the final point of truth. It's sort of the supreme court of sort of the entire system that underlies all payments and contracts and things of that nature. And we can build layers on top. And layers on top is sort of one of the narratives when it comes to building scalability. And we're dealing with issues with regards to limited block space. And it's as if everybody in the world must process and store all the data worldwide that we agree to store. And oftentimes the solution when it comes to scalability is to have not everybody in the world compute everything, but you have localized computation between people. You compute stuff, I compute stuff, and then later we tell the blockchain afterwards, and then our information is enforceable. Right now, the way we do transactions on Bitcoin, Ethereum, et cetera, it's like everybody in the world sharing a single Wi-Fi connection together. You can increase the speed of the Wi-Fi connection, but ultimately, if everybody in the world is sharing a single connection, that's very, very difficult to really, for example, build entire application platforms on top of the blockchain. So that's fundamentally the thematic elements that is interesting when it comes to scaling. They cut this part off, but fundamentally, scalability, privacy, and multi-chain interaction is oftentimes the same problem. And when you talk about privacy solutions, oftentimes they give you scalability benefits. And when you talk about interchain communications, like communication between blockchains, that also gives you scalability benefits. In addition, if you primarily focus on scalability, for example, Lightning Network, 闪电网络, was primarily designed as a scalability solution, but it also incidentally gives you significant privacy benefits because not everything goes on the blockchain. So oftentimes when you talk about scalability, it's about a couple topics concurrently that all interrelate to each other and oftentimes have multiple benefits. And I find that kind of interesting because that means that it's very, very hard to do censorship on the blockchain if you want true scalability. Like you can be building in certain types of like privacy invasive structures, but oftentimes inherently due to the technological properties of scalability on the blockchain, you're probably more than likely going to get significant privacy benefits and censorship resistance as well when it comes to these types of constructions. An example of that is that locally computed contracts only show the final result. And that's a scalability reference and tool in our toolbox. Multi-chain solutions such as Plasma often create significant scalability benefits as well. And what we're dealing with is that we're dealing with fundamentally a synchronization of states across multiple participants, right? Lightning is designed so that two parties can do an infinite number of transactions, but they tell the final result to the blockchain, and neither party can cheat in between, is sort of the design of that. But that means that the transactions going between remains private. Similarly with Plasma, the construction is inside the Plasma chain. If the participants agree to keep things private, then maybe not all the data gets released to the blockchain, and it ends up just being a hash of perhaps gigabytes or terabytes of data. And that means that you're dealing with states in one context, whether it be two parties or a set of participants, and releasing data which is enforceable to another context. And in order for that to be efficient, oftentimes you have significant privacy benefits and scalability benefits at the same time. So when we're talking about scalability projects, Lightning Network and state channels is an example, and what that gets you is significant scalability when it comes to payments. It changes payments from being a circuit switch type, a packet type system into a circuit type system, whereby every time you make a broadcast, you make a payment. And that's sort of like everybody in the world has to process it at once, and that's very expensive. Instead, what you do is you say, okay, these two participants do some trade, and then there's a network of participants that do trade off-chain, and then ultimately they release the enforceable stuff on-chain, and that way the chain is sort of a supreme court of the entire network. State channels, do a similar thing for smart contracts on platforms such as Ethereum. Plasma, recently released by me and Vitalik Buterin, on Ethereum, is that it gives Ethereum scalability and is one of multiple Ethereum scaling strategies, along with sharding as well as state channels, is that it gives you the ability to launch your own blockchain inside Ethereum. So you can run a private chain, for example, a private enterprise consortium chain inside a public network. And you ask yourself, well, why do you need that? Well, one, it gets you significant scalability benefits from just using the public network alone. In combination with sharding, you should see significant scalability benefits with that. But what's interesting is that it gives you enforceability with private chains. And private chains have this problem of, well, we all agree, let's say you have 10 companies agree to run this private chain. They can all agree to screw each other over. It's like the majority of the private chain participants agree to screw over the minority. Well, then the minority is sort of out of luck, right? At that point, they have to sue each other, and that's a very expensive and costly process. What I think is interesting about a lot of these emerging scalability solutions is that they let you run private networks on top of public networks. And the benefit of this is that the private network is enforceable on a public network. That means that the activity you do on a private network does not have to be disclosed or managed by the public network. But if any party tries to act maliciously or Byzantine in some way, then the public network can enforce it, and nobody controls the public network. So you have assurance of this enforcement. That's why I've been giving examples of the public network as the supreme court for sort of computation. Sidechains are another example. A lot of FedPeg sidechain constructions are basically consortium chain constructions. I'm not going to go into those. Mimblewimble is an interesting construction because it allows for rapid synchronization of the blockchain, and it uses cryptographic proofs to be able to prove state transitions. And using cryptographic proofs and cryptography to prove state transitions allow us to compress the amount of data when it comes to ensuring the most current state is valid. And that gives us significant scalability benefits. Sharding, for example, the excellent work in the Ethereum Foundation is doing on sharding is going to be an interesting aspect with scalability. That's basically making on-chain or partial on-chain scalability more viable. But effectively, that's dealing with parameters with failure modes when it comes to data replication. Data replication is a very important topic in this because when you deal with systems where not all participants have all the data, right now all blockchains presume that all participants have all the data, then there is a chance that there could be data loss, and it's something which needs to be managed as part of any type of scalability design. ZK Snarks, a lot of people assume it's a privacy system, but it also gives you scalability. Like I said earlier, oftentimes privacy systems give you scalability because what happens is you can have committed proofs that have activities. For example, you could say, okay, we're launching another separate chain and we have snarks commitments on various data, and that can give you enforceability across different contexts. Interchain contexts, management between blockchains is going to be an emerging and defining narrative within 2018. Simply due to scalability concerns, as well as interaction between because there are many blockchains. We all check CoinMarketCap all day, well, those of you that do, I don't really, but that sort of you can see the amount of coins and tokens involved, and the interaction between them is going to become very important, and oftentimes these mesh with scalability concerns. DAG research also is a potential area of research with scalability. I do warn that DAG is basically filled with bullshit in a very, very upfront way. Anyone that claims to do DAG might be BSing you. An example of that is IOTA, which straight up doesn't work. If IOTA worked, we would have had cryptocurrencies 20 years ago. That's not to say DAG is broken. There's a lot of interesting DAG research, but it is a challenging problem and oftentimes involves deposits and constructions around that. It's an awesome area of research, probably at least a year away at the minimum, but has a lot of interesting opportunities when it comes to these types of scalability constructions. So I'm going to go over this real quick. For the technical audience, we're talking about, it's sort of like, how do I reach my conclusions when I think about scalability? Trade-offs, fee market versus capacity. How do we deal with constraints when it comes to, needing basically transaction fees for the system? Are we dealing with bytes or velocity of money, like speed of transactions or limiting transaction flows? Global state versus local state is another interesting topic. Net settlement, I talked about that earlier. Time is going to be an interesting component when it comes to synchronization of different states. Reconciliation of the different states. Oftentimes people defer to time. People talk about blockchains, it's going to make it things so fast and everything like that. And basically a lot of those narratives are also bullshit, right? There's a reason why T+3 exists in the equities markets, right? It's not because we can't do it fast enough, right? We have computers. T+3 exists in order for security of systems, for synchronization across different states. And in the blockchain space, we have this problem as well. Don't expect it to be fixed. We can do near instant delivery, but near instant settlement is difficult, right? People confuse settlement and delivery, right? We're talking about clearing, settlement, delivery. Don't mix them up. They're very, very different, right? There's a difference between saying who has record of whose gold deposits are in the record, and actually getting gold on your front door, right? There's a difference between settlement and delivery. Don't mix it up. And it's very important not to mix it up for scalability. So implications. Like I said earlier, enforceable private chains is an interesting theme, right? In 2018, anyone doing in private chains for the past 3 years has been bullshitting you as well. There's a reason why there is no running enterprise blockchain, right? In terms of with serious use. There's a couple here and there. Nobody uses it. There's a reason. It's because you should be using SQL, right? So the blockchains are only useful if it's enforceable in a decentralized system. So when it comes to scalability, it will incidentally make it so that you can do enforceable private chains on public networks. It can give you new business models when it comes to scalability. Like I said earlier, maybe you can have entirely new application sets, not possible today in the blockchain space. Things that require, potentially gigabytes of data when it comes to, let's say messaging and things like that. We're going to be dealing with situations with many, many different blockchains, and that may change the context of what we're dealing with. It's possible that we can deal with a hierarchy of blockchains, right? When it comes to running Plasma blockchains inside Ethereum, or maybe it's like a peer-to-peer model with, perhaps lightning channels between them or various other constructions. I think that remains to be seen, but I think it's very promising in terms of the Ethereum space right now. That's editorializing on my end. But, there could be, necessity for tokens and coins to secure the value of these chains, right? One thing that remains to be seen that would be interesting for everybody in the room, I think, is the viability of proof-of-stake models. And proof-of-stake models fundamentally give a necessary justification for a token itself. I would say probably 90% of the tokens out there don't need a token, right? I think that should be obvious to everyone in this room. If it's not obvious to you, you should probably not be touching this stuff. On a fundamental level, if proof of stake does work, right, what we can do is saying, okay, if proof of stake works, fundamentally by owning coins or tokens, you have a proportional share to produce blocks. And when you have a proportional share to produce blocks, you have a proportional share of the transaction fees within those blocks. And what that means is that, in effect, by owning tokens, you have residual ownership of operating this network. And it's not a passive actor, too. By owning tokens, you're creating blocks as well. So you're not like a passive investor, not even on the board and just doing something passive. You're taking individual activity, which has discontinuous return dependent upon your activity. But it's interesting insofar as that, what you can get is the potentiality of a future where, by owning tokens, you have the right to own proportional shares. So I think these are a couple things remain to be seen when it comes to where we headed with scalability, and most of my talk is just sort of exploring these narratives with you. Thank you so much for your time.